one?
Yes, sir.
Okay. So we will start the session with a discussion of mock one, the paper four mock set one, and then after this we'll discuss the set two as well. The last two questions were left. That's why we will complete the last two questions and then we move on to the set two. I have discussed about the power, the pressure, the motion of the particles, specific heat, formation of image, and the diffraction, as well as this efficiency. So question 9 is, we did not discuss question 9. Question 9, figure 9.1 shows a simple AC generator. What is an AC generator? AC generator, the kinetic energy uh, turn into like changes into electrical energy. When the coil rotates between the magnetic poles, there is a change in the magnetic field, and change in the magnetic field induces EMF. And the cycle, what we receive output, AC increases to maximum, then decreases, then increases to negative maximum, then decrease, and so on. That is the cycle of the AC. And how you will identify in exam that this is a AC generator. So if you see a slip rings, if you see slip rings in the diagram, it means it is an AC generator. But if it was a DC motor, then there will be split rings will be there. So that's how we can distinguish between an AC generator and the DC motor. The question is, explain why there is a voltage induced in the coil when the coil is turned. You can use your mic, you can use chat, or you can also use the screen annotation to answer this. So what will happen? Why there's an induced EMF? So as the coil will rotate, the rotation of the coil, what it produces? It produces a change in the magnetic field. So rotation of the coil produce a change in the magnetic field or a magnetic flux. This is the first thing we just started now. For those who just joined now, I did not start any topic before that. This is the first part of the question, that this is set one. Today we will discuss set one and set two, and tomorrow session we'll discuss set three and four. Paper four. So what are the points you should include? As you can see, this is a AC generator. So in an AC generator, when the coil rotates, there will be a change in the magnetic field. Don't start your answer with the because. That is not the right way to start any answer. So the magnetic field lines are cut by the coil, but that is one mark. The coil cuts the magnetic field lines. And then what will happen? So coil cuts the magnetic field line, cause the change in the magnetic field. So in short, what you will mention here, you will mention the change in the magnetic flux will induce EMF. So how you score the mark? One mark is for using a term, either a magnetic flux or a magnetic field. If you use the term magnetic flux or a magnetic field, you will score 1 mark. And what about the second mark? The second mark is for the change. If you use the term change and use the term EMF together, it will score the second mark. So as the induce EMF. So the mark distribution, like if I write the answer, the structure answer for this, you will mention, because the space is given, the rotation of the coil produce change in magnetic field. You can use this term, or you can say magnetic flux, or you can also say cuts the magnetic field. So rotation of the coil produce a change in magnetic field, or may change in magnetic flux, or rotation of the coil cuts the magnetic field, and the EMF is induced due to the change in magnetic field. So whenever you see a changing magnetic field, changing magnetic field will always produce EMF. You cannot use the term change EMF. That is not the right term. You will mention when the coil rotate, it cuts the magnetic field or there is a change in the magnetic field. And because of the change in magnetic field, there is always an induced EMF. So this is always the structure answer whenever they ask why an AC generator produces a current. So you should always write this answer. Or why there's an induced EMF in the coil. When the coil is moving in a magnetic field, you will always write this structure answer. The next is figure 9.1, the coil is horizontal and the voltage is 6. So because when the coil is horizontal, we got the maximum voltage. In this case, so let's say the maximum voltage is +6 and the negative maximum is -6. So the coil is horizontal. When the coil is at this position, we have +6. So when the coil will rotate 180 degrees, how we can identify the difference in the diagram for AC generator and a DC motor? In AC generator, you will always see the slip rings. These slip rings are there. But if it was a DC motor, what you will find the split rings. So that is the main difference between the AC generator and a DC motor. So a DC motor is having a split ring, but AC generator is having the slip rings. So what happened when the coil is at this position, we got the maximum voltage +6. And DC, yeah, that's also a valid point, Farzam, that DC will also have a supply because in a DC motor, we pass the current and cause the rotation. In AC generator, we rotate the coil and produce the electricity. So when the coil is horizontal, we got +6 volts. When the coil is vertical, what will be the voltage? So the voltage will be 0. So when it is vertical, there is no induced EMF because the change is no change. And then again, when it is horizontal, like AB is on the right hand side, when it rotates 180, so it will be -6 volts. So now the question is, figure 9.1, the coil is horizontal on the left and AB is on the left hand side and the voltage output is 6. On a figure 9.2, draw a line from each shaded box to one circle voltage, how the voltage output will. So first, when AB is on the left hand side and the coil is horizontal, like AB is on the left hand side and the coil is horizontal, we got +6 volt. When AB is horizontal and the coil is on the right hand side, so when it will rotate, it is horizontal, but the position of AB has changed. AB is on the right hand side. So there will be induced maximum will be there, but it will be opposite. That's why this will be -6, -6. Then if AB is at the top or AB is at the bottom, means the coil is vertical. Like if the coil is vertical, the induced EMF is 0. Even AB is at the top, or when the coil is vertical, AB is at the bottom. What will be the induced EMF when it is vertical? There is no induced EMF. That's why it will be 0. So in a AC generator, which change in the magnetic field induced EMF when it is horizontal, maximum. The only difference here, AB was on the left hand side. Here AB is on the right hand side. So both cases it will be maximum, but opposite maximum. If this is +6, this will be negative. But when the coil is vertical, there is no change in the magnetic field or induced EMF. So the induced EMF will be 0. So this will be 0 here and 0 here. This is a cycle of a AC generator which changes as the position of the coil changes. The negative sign actually shows a direction of the current. The negative significance of a negative sign in the voltage or a current is a direction actually. Like the direction is opposite. The next question is both AC generator and a DC motor contain the coil and the brushes. Figure 9.1 shows how the brushes are connected to a coil in AC generator, diagram to show how brushes are connected to a coil in a DC motor. So how brushes are connected? So we have to draw the split rings, split ring commutator. And what is the function of the split ring commutators? It allow the current to flow in one direction, so the coil will continue to rotate. We have to make split ring. So if you want to draw a split ring, you have to, yeah, good. You just have to split the ring, like they make a ring and split into half and draw the carbon brushes. So there should be a gap between the, and then these are the carbon brushes. And always a label diagram. So this is representing the split ring commutator and this is a carbon brush. So main difference is a split ring commutators and the slip rings in AC generator and DC motor, as well as another one is having a supply, a DC motor is having a supply, but AC generator does not have any supply. Like we produce electricity by a generator. Explain why there are forces on the sides of the coil in a DC motor. So if I draw a DC motor here, full DC motor, what is you don't have to draw full DC motor in this part. You just have to draw the split ring. So a DC motor consists of bar magnet, opposite poles are there, and a rectangular wire or rectangular coil between the poles. Then this is connected to the split ring and the carbon brushes. Then connected to a supply. A switch is there. So this is actually a DC motor. So what will happen? The question is why there are force acting on the sides of the coil in a DC motor. So when the current is passing through a DC motor, when we close the switch, the current start to flow. So as there is a current, there will be a magnetic field because whenever there is a current, current produces a magnetic field. So the wire produces a magnetic field, like two magnetic fields are there. One is a magnetic field of a magnet, which is from north to south, and another is a magnetic field of a wire, which is circular. So what will happen? A current passing through a wire produces a magnetic field. So magnetic field of a wire interact with the magnetic field of a permanent magnet and experience a force. And because the direction of the current is opposite in both sides, like if this was side AB, the direction is, let's say, from A to B, but for C and D, the direction is from C to D. Like one is upward, another one is downward. So both sides, the current will produce, and the current produces a magnetic field. So magnetic field of a magnet interact with the magnetic field of a wire. That's why the two ends of the two parts of the coil experience a force. So answer here, the wire act as a current carrying conductor in a, no need for mention change in magnetic field. Just this is fine, but more structure answer. Why the question is why there is a force on the sides of this AB or DC. For AB, if you work out, you have to use a left hand rule. Fleming's left hand rule, if whenever you're working out the force, so the side AB will experience a downward force when you apply a left hand, and side CD will experience an upward force. The green lines are representing the magnetic field of a magnet, and the brown lines are representing the magnetic field of a wire. So what should be the more structured answer for this? The wire carrying the current, it's of only one mark. So the wire carrying the current produces magnetic field which interact with the magnetic field of magnet and experience, or you can say which cuts the magnetic field of a magnet and experience the force. This is more structured answer. The brown circles are won't we give a reference to the fact that the opposite oppose the change. No need to oppose mention that. It's of only 1 mark. So the idea, the simple idea about the wire experiencing a force, that you have a magnet, there's a magnetic field of a magnet which is from north to south, and there is a magnetic field of a wire which is carrying a current. When wire is carrying a current, there is a magnetic field of a wire. So two magnetic fields actually interact with each other, and that causes a force on the wire. And for DC motor, we use a left hand rule. For AC generator, we will use a right hand rule. Now, first thing we have to state why there is a force. It's not like why the force is opposed. The question is why there are forces on the sides of the coil of DC motor. So what will happen? There are two magnetic fields, like two magnets are there. One is a magnet due to, or a magnetic field due to a wire which is carrying a current. Another one is a magnetic field due to a magnet which is already having its permanent magnetic field. The green lines are representing the magnetic field of a magnet, and the brown lines are representing the magnetic field of a wire. So simple idea, whenever there is a current in the wire, this will always experience a force. So interaction of the two magnetic field cause the force. That is the first thing we will write. And then what about the direction of the force? That is the other point, that they always try to oppose the change in a magnetic field. So in short, what is a simple answer here? That a wire carrying a current produces a magnetic field which cuts the magnetic field of a permanent magnet, or two magnetic fields interact with each other. That is why there is a force on the wire. Is it clear, this one? So why the wire experience a force? That is interaction of the two magnetic fields. One is because of the wire, one is due to a magnet. Magnet produces magnetic field, and the wire also produces its magnetic field. So even sometimes they give you a question like this, they give a magnet and they say a wire is carrying current into, like there's a current which is going into, and they ask why the wire experience a force. So what should be your answer? You will say the same thing, that there is a magnetic field of a magnet which is from north to south, and there is a magnetic field of a wire which is carrying a current around it. So two magnetic fields interact. That's why the wire will experience a force. How to find the direction of the force? For that, we will use a Fleming's left hand rule. Yeah, the current carrying wire has a magnetic field which interact. That's the right answer. Interact with the permanent magnetic field of a magnet. That is why it experiences a force. Over here, we will not use a right hand grip rule is to find the direction of a magnetic field or a magnetic flux, and to force, we use a left hand rule. Whenever we want a force, direction of a force on a current carrying conductor, we use the left hand rule. The next is the carbon 14 is an isotope of a carbon which undergo a radioactive decay with a half-life of about 6,000 years. What is the meaning of a magnetic flux? Magnetic flux means how many lines are there in a unit area. How many lines in a specific area, that is called a magnetic flux. So if you say change in a magnetic field or a change in magnetic flux, that's the same thing, because if the magnetic field will change, the magnetic flux will also change, because how many lines in a specific area. The next is, so describe what happened during a radioactive decay. So the age of a sample of a wood is found using a carbon 14 that it contained. Look, what actually happened in a radioactive decay? Radioactive decay is actually a random and spontaneous emission of radiation from the radioactive nuclei. So what happened in a radioactive decay? It's a random and spontaneous emission of radiations from the radioactive nuclei or unstable nuclei. So what are the points which will score a mark? Like what happened in a radioactivity? One thing is the emission from the nucleus, spontaneous and random. Even it's very important term because random means there is no order and spontaneous means it cannot be triggered by the changing conditions such as temperature, pressure. So when I use the term random and spontaneous emission, that is one mark. And of radiation, that is another mark. And instead of radiation, you can also use the term random and spontaneous emission of particles such as alpha, beta, or gamma. Gamma radiation, alpha and beta are the particles. You're not supposed to say anything related to a neutron composition. You just have to say that a radioactive substance is it's like unstable radioactive substance, unstable atom or a nuclei or a radioactive nuclei. When it emit out radiation such as alpha, beta, and gamma, random and spontaneously, we call that as radioactivity. And that is what happened in the radioactivity. The next we have the count rate for a carbon-14 sample. Initially, it was 1600 counts per minute. And on the figure, graph how the count rate will change over 24,000 years. So it is originally 1600. We don't have to convert the unit. The originally 1600 and we want 24 years. And the half-life is already given in the beginning of the question. They said after every 6,000 years, it will become half. So this is the first one. What is half of 1600? Half of 1600. That will be 800. So after 6,000 years, 10 boxes equals to 4,000. No, this is the 10 boxes equals to 4,000. So each is representing what? Each is representing 400. So this will be 4,400, 4,800, 5,200, 5,600, and this will be 6,000. So at 6,000 years, we'll have this. Then after 12,000, like what is half of 800? Half-life is given in the beginning of the question. The first beginning of the question, they give us the half-life, that the half-life of this carbon-14 is 6,000 years. I will show that once the student annotate, I will show that. So this is the count rate. And then what is half of 400? It will be 200. So 18,000 will be somewhat 1, 2, 3, 4, 5. This will be 18,000 and 200. And then after what is half of 200? It will be 100. So somewhat here it will be. So, and we have to complete the exponential decay here. So it will always be a curve. Decay is always a curve in the beginning. So this is how we will join. Okay. So that's the decay which we have to complete. And in the beginning of the question, they mentioned the half-life, which was 6,000 years. So after every 6,000 years, it will become half of its original value. The next question was, name the apparatus used to measure the radiation from a sample of a wood and describe how it is used to measure the count rate. First, which apparatus we use for... So the main apparatus is a Geiger-Miller tube or a GM tube is there, or a Geiger counter. These are the right terms. If you use a Geiger counter, GM tube, these are the right terms. And how it should be used, like what we should do, not Geiger counter tube, Geiger-Miller tube. And how it should be used. So instead of writing this, what we do, we record source and the screen shown reading and counts radiation. First, what we should do, we should record the radiation without any source, like record the background counts with no source. And then we should record the radiation with a source. and then subtract the two values to know the radiation from the source. That's how it should be used. So how the apparatus should be used? How we should use an apparatus? So what we should do? We should record the radiation without the source, and record the radiations with source, and then we will subtract to find radiations from the source. That is how it should be done. So always, whenever you use a device which is detecting a count, because first you should record how many radiations are with source, without source, then how many are with source, and then subtract to know the total radiation. Describe how the count rate from a sample of a wood is used to find the age. How we can find the age of the sample? So what we should do, a sample of a wood have a radioactive decay which each day have a different half-life. No, half-life having each day, each decay having a half-life, so three pre-emissions rate with it's a life. Okay. Yeah, this is the right answer. And what is the simple short answer for this? Yes, for example, that is good. This is the right answer. What you can do, you can record the radiation from the piece of the wood, and you can record the radiation from the fresh sample, and you compare the radiations between them. Like example, let's say we have a piece of a wood which we got from the fossil. So let's say it is 2 gram, and then we will take a fresh sample of the same type of a wood that is also 2 grams, and we'll compare the amount of the radiations which are coming out. Let's say this is giving us 100 radiation, and the fresh sample is giving us, just an example, let's say 400 radiation. So what we will do, we'll compare the radiation from the fresh sample and the old sample, and compare how much it has changed. Like the fresh sample is 400 and the old sample is 100. So how many times it has changed? So if it was that time, it like this was fresh, it should supposed to be 400. Then after 400, it will turn into 200. After 200, it will turn into 100. So we'll find how many half-lives are there. And from the half-lives, we can determine the age of this sample or a record. So describe how the count rate from a sample of a wood is used to find the age. So what we will do, we'll record the radiation from the fresh sample and the old sample. Then we'll compare the radiations, and we'll use the half-life to know age of the sample. Is it clear how we can determine the age of the fossil or the sample by using this radioactivity? The next is the question related to space physics, and honestly, I was really amazed and by the fact that some of the student wrote a very wrong answer for the order of the planets. I don't expect this type of mistake, so it's fine. You forget something, but at least this is a very like a important thing that you should know the order of the planets in our solar system. So we have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Neptune, Uranus. So till Neptune we have to write. The distance from the sun is given, the orbital period is given, and the average surface temperature is also given. Complete the table 11.1 by adding the names of the three planets that are not given and calculate the orbital speed of the Mars as it travel around the sun. And we need in kilometer per second. So the distance from the sun, actually distance from the sun is a radius. Like this is our sun. Here's good. So this is representing our sun. And here we have the Mars. The distance from the sun in kilometer. This distance is given. How much it is given? That is 2.3 into 10 to the power 8. So actually this is the radius of the, because the Mars will move in a circular path. So means this is the radius is given. And orbital speed, the formula for orbital speed, it is 2 pi r divided by t, where t is the orbital time. So it will be 2 into 3.14 into 2.3 exponent 8, that is the radius, divided by the time. So the time is 5.9 exponent 7 second. So when you divide, you will get 24.7 kilometer per second. So, and we expect like Earth, it's about 30. As the planets are closer to the sun, they have a lower gravitational potential energy or a higher kinetic energy. So the planets are near the sun are moving at a higher speed as compared to further from the sun. The next says describe a relation between a distance of a planet from a sun to its orbital speed. So what is the relation? If a distance increase, the orbital speed will, as a distance increase, the orbital speed will decrease. It will not increase. Like the planets which are closer to the sun, if you work out, you will find that they are moving faster. Why the planets closer to the sun are moving faster? Because they all have the same energy, the kinetic and the potential. The sun, the total energy is conserved. So we have a Mercury, we have Venus, we have Earth. So because the Mercury is closer to the sun, so it will have a smaller gravitational potential energy. So smaller gravitational potential energy, so it will have a greater kinetic energy. So the Mercury will move faster. What about the Venus? Compared to Mercury, the Venus is having a greater gravitational potential energy, so the kinetic energy will be lower, so it will move slower. Yeah, I'm talking about orbital speed. You're right, Farzam. Your answer, I'm talking about orbital speed, not the orbital period. I was speaking about orbital. You wrote orbital time. That is right. I'm talking about orbital speed. My discussion was based on orbital speed, not about the time. So I just cross it to give an idea about orbital speed, not the time. But what about the time? As you can see, this is correct. That what will happen, that as we move away, because they will travel slower, so the time, it will take much longer time. Like you can see, this is much longer than this one. So your answer is correct. I did not say your answer is wrong. I said if I'm talking about orbital speed with reference to that, it is wrong. But orbital period is correct. That is the right answer. That what will happen when we, as the distance increase, the orbital period will also increase. And you can see from the table itself. So why the planets move slower? The further they get, the slower they move, because what will happen? The gravitational potential energy is higher, so lower kinetic energy. So that's why the speed is lower. Describe the relation between the distance from the sun and the average surface temperature, and in description include any anomalies, the result. Like the anomalies means that which is not following the order. So which one is not following the order? As you can see, generally what is happening, if you see from the temperature is decreasing generally, but what is the anomalous here, that Venus is not following that order, like moving from Mercury to Venus, We observe there's an increase, rest all of them are decreasing as the distance increase. Anomalous, yeah, anomalous result or anomalies is the same thing. Means a result which is not in a order. If I compare the trend here, you can see that the temperature of the surface temperature appear to be decreasing except this one. So this appear to be anomalous result, the result which is not in the range. Why Venus is like this? Because not only the surface temperature not only depends on the distance from the sun, it also depends on the atmosphere. Like what kind of gases are present in the Venus. So Venus contain mostly the atmosphere of a it contain mostly the atmosphere or a region depends on the surface, like what are the material the surface is made up of, plus the surrounding. So that's why it is not following the same order. No, no, it is like this. The data is not a mistake. This data is correct because look, remember one thing. When in Cambridge, when they give you the question, the questions are fact-based question. They are not like making any random thing that or even the values when they use in the experiment. In paper six, those experiments are done actually first, and then they give you the results. So it's all the values are true values. There's no like arbitrary values or assumptions there. So the correct answer for this one is the trend that it is decreasing except from Venus, which does not follow the trend. So as we further go from the sun, the planet temperature is decreasing except for Venus. It is much hotter. And what may be a reason? Mainly greenhouse effects are there or greenhouse gases might be there. That like high percentage of a greenhouse gases may result in this anomalous or anomaly. Yeah, if you don't include, you will lose the mark here. So it's of 2 marks. One is the trend that it is increasing or it's getting cooler, and the one is for not including the anomaly. You will 1 mark is for that. Like if you include that, you will score that mark. So this was mock set one. Greenhouse gases such as carbon dioxide, methane, water. These are the greenhouse gases. They have a tendency to trap the heat radiation so that the average temperature of that region will increase. We call them as the greenhouse gases. Do we need to memorize this table? No, you don't have to memorize this table. That if any question is there related to a table, they will provide that. And they ask to interpret, like use a table. So you don't have to memorize anything here. The order, actually, it's the order. Yes, order you have to memorize, but not the table. You don't have to memorize the number. You have to. It's obvious that you should know at this level the order of the planets like Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. That is the order is in there, but not the numbers. Numbers they will not ask directly what is the temperature of the Mercury, what is the average. That will not be there. The Earth distance, no, you have to learn about light year, not the Earth distance. You have to learn about light year. Like 1 light year is equivalent to what? But you don't have to. Hubble's constant and the light year are the values which you should know, but not the distance between the sun and the Earth. They will provide that. So we'll discuss mock paper 2, set 2, join from the same link, and I will just open that. We'll start the discussion.